Hello. In this video we will talk about constructing the confidence intervals, and we continue reviewing quiz 3 questions. Let's look at this question. How smart is your phone? A random sample of 9 smartphones being sold over the internet in 2013 had the following prices in dollars, and here you see the prices. Assume the population standard deviation is sigma equals 86. Explain why it is necessary to check whether the population is approximately normal before constructing a confidence interval. Why? So let's look at the section in the textbook and check what we have here in this section to refresh. Assumptions for constructing a confidence interval for mu when sigma is known. What is mu? I remind you, is the population mean. This is section 8.1, constructing the confidence intervals when the population standard deviation is known. We have a simple random sample, that first assumption, and the second assumption, the sample size is large, greater than 30, or the population is approximately normal. So if we don't have a sample size large, as we see here with the size greater than 30, then the population must be, we need to know for sure that the sample was from the population that was approximately normal. So let's look at the question again. We have only 9 smartphones in the sample. 9 is less than 30. That's why, to continue on, we need to check whether the population is approximately normal. Again, I remind you from my previous video, to check that the population is approximately normal, you can use the dot plot. So you have this data, and you plot this data along the number line and see how the dots spread around. The dots pretty much equally spread, a little bit longer here, but it's all pretty much equally spread. No visible outliers. So we can say it is reasonable to assume that the population is approximately normal. Next step for the same question. If appropriate, construct a 99.5% confidence interval for the mean price for all phones of this type being sold on the internet. Round your intermediate step to 3 decimal places, round your insert to 1 decimal place. Now we don't need intermediate step because we will do this all on TI-84, and I'll show you how. So first let's look at the data, because we need to enter data into list, and we're going to use a calculator here. So to enter the data into list, we use stat and enter. So here's some data I had. I clear the whole list. Don't use delete above on the list L1 or L2. And now we enter the data 190. Otherwise, your calculations will be wrong. Check if the numbers you see in your list L1 and in your textbook are the same. So once you entered and you're sure that their sample is from approximately normal population, you go ahead and use stat again, and here choose test. Here we have a case of 2 commands which allow us to calculate confidence interval. Z interval for cases when sigma is known, when the population standard deviation is known, and T interval when the population standard deviation is unknown. So in our case we have sigma, so I'll go with the Z interval. And now I choose input. We have data, raw data. If we have stats, that means we have the sample mean, and we enter that value. So here we enter 86. List where your data is stored. In my case, it's list L1. Frequency, you can leave 1. And confidence level. Confidence level is here. It is in decimal notation, not percent. 0.995. Make sure you enter that 5. And then you calculate, and you have your confidence interval. So they want us to give answer around your answer to one decimal place. So it will be 167.6, comma 328.6. That's the answer. So this way we we estimated the population parameter, population mean, to be between these two numbers, 167.6 and 328.6. So that's how the confidence interval works. Here's a similar question. In a simple random sample of 100 electronic components produced by a certain method, the mean lifetime was 125 hours. Assume that the component lifetimes are normally distributed with population standard deviation sigma equals 20 hours. Round the critical value to no less than 3 decimal places. We do not need critical value here. If the critical value is Z alpha over 2, I remind you, in this case we use critical value if we do it by hand, but since we're using TI-84, we will construct an 80% confidence interval with TI-84. Where to find the command? We have sigma, so we will use Z interval again. Z interval is 7. You can go straight to. This time we use stats because we don't have data for this sample. The sample was collected and the mean lifetime was calculated. So the mean was calculated. Sigma is 20. And the mean lifetime 125. The sample size is 100. So the level, the confidence level is 80% or 0.8. Calculate. We calculated the confidence interval, and make sure you follow the instructions. Round the answer to nearest whole number. So if it's to nearest whole number, it will be 122, 128. That's the 80% confidence interval for this problem. Find the sample size needed so that in 95% confidence interval we'll have margin of error of 4. And a sample size we need to refresh in our memory the formula for the margin of error. So this is in your book as well. I will show you this margin of error actually here. Margin of error is this expression, Z alpha over 2 times sigma over square root of n. N is the sample size, sigma is the population standard deviation, and Z alpha over 2 is the critical value. So let's go back to the question. So the margin of error they want us to have is 4. So let's write this down here. So margin of error, let me start over. So the margin of error is 4. So M equals 4. That's one way. On the other hand, Z alpha over 2 times sigma over square root of n. So what do we know from here? That's the margin of error. We know sigma is 20, n is we need to find unknown. Z alpha over 2 we will find from the fact that we're talking about a 95% confidence interval. So we're looking at the normal curve. So 95% is in the middle and 5% left for these two pieces. So where is Z alpha over 2? Z alpha over 2 is this critical value, or Z score. So this Z score separates 95 plus 2.5% to the left from another 2.5% to the right. Why it's 2.5? Because 2.5 and 2.5 is 5%, added to 95% in the middle gives you 100%. So how to find Z alpha over 2? We will use inv norm command on your calculator. So I'll show you how to do so. We will use the standard normal curve with mu of 0 and standard deviation sigma of 1. Let's look at this. So let's find inv norm. We go in second bars, and inv norm is the number 3 command here. We go to number 3 inv norm, area to the left. On my calculator it's always area to the left, so I need to add 0.025 and 0.95. So 0.025 plus 0.95, and I get 0.975. That's the area to the left of this critical value. This is the area. Now my calculator that I use here is kind of old-fashioned. Newer calculators allow you to choose the area. Here they have additional row where it says area left, right, and center. If you want to use that, you can use 95.95 and center. That's what it gives you. But in my case, it will be 0.975 area to the left. And this is a standard normal curve. So I just need Z alpha, the critical value. The critical value will be 1.96. We round to 2 decimal places. Even you round to 3, it still will be 960. So the critical value 1.96. Sigma is 20. Square root of n is unknown. And m, they want us to be 4. So once you have this equation, you solve it. You multiply 1.96 and 20, you get 39.2 over square root of n equals to 4. So square root of n will be 39.2 divided by 4. So let's use our calculator and continue on here. So 39.2 divided by 4, that's square root of n. Now we square this number and we got 96. So n will be, so again, let's look at this, 96.04. If I take 96 for the sample size, that will be not enough because it should be 96.04. So I cannot take 96.04 because those are integers, so I have to answer 97. That is important, that in this case we always round up. And the answer is we need to have a sample size of 97 to construct a 95% confidence interval with margin of error 4. Again, I remind you here that everything is important. If we change margin of error to 5, this number will change and the n will be different. If we change margin of error to 1, this number will change and n will be different. And that's how we do this. So next step, a sample of size 54 has sample mean of 54.8 and a sample standard deviation S equals 9.5. Do you see a difference that in previous case we had population standard deviation sigma? This time we have a sample. So that's why when you need to construct a 98% confidence interval for the population mean mu, you have to use a command T interval for the same reason that I just mentioned, that we don't have the population standard deviation, but we have a sample. And when you have a sample, that's a slightly different algorithm, which is in a command number 8 T interval. So again, input is statistic. So we're going to put x is 54.8, sample standard deviation 9.5, sample size 54, and confidence level is 0.98. So 0.98, and you calculate. So here we have confidence interval. You can see larger here result, and round to the nearest one decimal place. So if we round to one decimal place, it will be 51.7, comma 57.9. So that's the answer. Part 2, if the sample size were 50, would the confidence interval be narrow or wider? Let's look at the formulas for constructing a confidence interval for mu when the sigma is unknown. So here, instead of Z alpha over 2, we use T alpha over 2, and instead of sigma, we use sample standard deviation. But the idea is the same. This is the margin of error, T alpha over 2, as you see here, times S over square root of n. So when square root of n is, or basically saying when n is less, square root of n is less as well, so the denominator is smaller, the fraction is larger. So that's why this quantity S over square root of n will become larger, and the entire margin of error will be larger. So that's why we need to choose the confidence interval will be wide.